Alright, www.survivalebooks.com is where I found this book, and this is um, table of contents, administrative instructions, grading certification instructions. This is the introduction of wheel, vehicle, clutches, transmission, and transfers. Lesson 1, fundamentals of gears, explain the principles of torque, the purpose of the type of the operation, gears and trains, explain the ratio, principles of gear and torque ratio, describe construction, operation, planetary gear set. Lesson 2, fundamental clutches, describe purpose and explain clutch operation, maintenance of clutches. Learning event 3, fundamental manual transmission power takeoff. Learning event 1, describe the type of the instruction and operation maintenance manual transmission. Describe the power flow, lubricating a manual transmission. Describe the construction operation power takeoffs. Describe the maintenance of power manual transmission and power takeoffs. Lesson 2, fundamentals of automatic transmission. Lesson 1, describe the operation and drivetrain mechanism and automatic transmissions. Learning event 2, describe the drivetrain arrangement, automatic transmission. Learning event 3, describe hydraulic system of the automatic transmission. And then lesson 5, fundamentals transfer case. Learning event 1, describe the construction operation transfer case. Learning event 2, describe the construction operation of sprag units. Grading instruction. Alright, introduction to wheel vehicles and clutches. We know that internal combustion can develop the rotary motion power at the flywheel on the back end of the crankshaft. We know that any time the rotary motion is power is available, it can be made to do work. Let's see how the type of this power is applied to various types of machines. If we think of the one-cylinder engine with a lawnmower, the power is delivered from the mower in one of two ways: in connecting two units with a belt or mounting a mower blade directly to the crankshaft of the upright engines. Belt-driven motors contain the devising, tightening, and loosening belts so that the mower can be started and stopped while the engine is still running. Some rotary motors have upright engines use a mechanical device consisting of discs to connect and disconnect the engine from the cutting blade. These discs are commonly called clutches. These purpose to provide means of the connecting and the disconnecting engine power from the machine to its separate supposed drive. The automobile engine must also be disconnected with the vehicle's wheels where the engine can be started. After running, the power of the engine must be ready for the use if the driver wants it. For instance, the driver must be able to make the vehicle go by engaging power smooth and gradually preventing twisting, breaking vehicle parts, keeping it jerking from the people or the load. Some means must also provide so that the engine can make the vehicle then go in reverse as well as forward. There must be some way to vary the speed between the engine and driving wheels so that the vehicle will be able to run at high-speed level roads as well as heavy loads up steep hills. Besides furnishing power to make up the vehicle move, many engines also have power. Such things as winches, hydraulic pumps also provide with the vehicle taking power from the engine, applying it into these devices as needed. Most Army trucks can be moved by power to all wheels front and rear, as this too requires additional units of engine power to each wheel. For the most part, the tasks described above are done by units called clutches, transmission, power takeoff, and transfer cases. It's the job of the mechanic to maintain these units. These will perform the job correctly. Subcourse is designed to provide you knowledge, construction, operation, maintenance of these units. Alright, your U.S. Army Light Wheel Vehicle Mechanic MOS 63B Skill Level 3 Course Wheel Vehicle Clutches, Transmission, and Transfers. Subcourse OD1005, 5 credit hours. Alright, lesson 1, fundamental of gears. Describe the fundamentals of the gears and train. Give information, construction, use, type of the gears, gear train, principles, operation, simply planetary gear set. Alright, learning event 1, explain what the principle of the torque. At the task of the familiar with the process of the winding our watch. To do this, simply grasp the winding knob between our thumb and the forefinger, roll the knob. This action causes the shaft to rotate inside of the watch, which in turn causes the watch to move the spring to wind. Let's think of another form of the winding action, the winding of the child's toy. How again, with the intent of the spring, with the energy produced, the spring trying to move upwind, spring trying to unwind, can make a toy work. They can be used with the winding toys as if the shank of the fits into the winding shaft with a fairly long finger grip, and to turn the key. The device is designed for one purpose. Turn the shaft will wind up the spring, and however the toy spring requires more effort than wind the watch spring, so finger grip is larger than winding knob of the watch. Suppose we try to turn the spring shaft without a key. By gripping it extremely tight, we might be able to turn a little bit, but enough to wind the spring tight. What is the reason of us not being able to winding it tight? To begin the inner end of the shaft of the fastest one end of the coil spring, the natural shape of the chip forms loose coils. When the spring is wound, the position and shape of the coil is changed as it becomes tighter. However, the large amount of the work is needed to wind the coil because of the steel spring and it tries to remain in the unwound condition. The work involved in this twist is applied with the winding of the shaft. The twist rotating effort applied with the shaft is called torque. Torque is the twisting effort that is applied to make anything rotate. We usually think as the work required rotate shaft. However, if you were to grasp one end of the barrel and tip it on the edge, roll it, and would be able to applying torque to the end of the grasp. The effort used to remove the screw cap of the jar is torque. Another example of torque is with a wrench and a bolt and nut and stud. In this case, you still apply that twist. But let's stop and think why. We could not have enough twist with our fingers to be tight and loosen a bolt, but yet it becomes quite simple that when we use a wrench, the reason becomes simple because the wrench provides lever action. We also know that if the wrench handle is long, we can turn a nut and bolt much easier than a short handle. Now let's think of the bolt with the nut and spring shaft of the watch of the toy. The ratchet of the shaft of the spring can be wound quite easily. A person would feel a little foolish winding in his watch with a wrench through it, and so they place the knob on the shaft. The knob is actually the device the same as if it were we had wrenches sticking out in all directions of the shaft. In other words, the knob being larger than the shaft provides a lever to overcome the torque required to winding the spring. Keep in mind the torque is twist, and we increase the twisting effort by using the lever. Now let's discuss a wheel vehicle mechanical employed for the use of torque. Let's start with the engine. The position is for piston is forced down on the combustion stroke, and the connecting rod is forced with the crankshaft throw down, but the crankshaft itself is kept from moving down into its main bearing with the throw force of all the shaft to rotate it. However, the shaft is hard to rotate because of the flywheel resists moving one or more other positions being forced up with the compression stroke. Therefore, the power stroke of the one piston must apply to the twist of the crankshaft, force the others up on compression stroke, and still have the power left over to do other work. You can see that a great deal of the torque is applied with the engine crankshaft. The purpose of the wheel vehicle to transport passenger or cargo. The only way this can be done is the vehicle wheels to move the vehicle in the direction and speed desired by the operator. This means that the wheels must be made to rotate. To do this, torque is applied with the shaft that drives the wheels. Same torque is applied with a wrench tightening a bolt. The amount of torque twist was applied with the shaft of the other given end point can be measured. To explain this, let's think of the stud as being turned into the threads of the piece of metal. For example, we say that the bolt or stud fits the threads tightly, therefore they're quite hard to turn even before it's tightened down. To explain the measurement of torque, we'll use the wrench and bolt. The wrench handle has 12 inches long, is marked at 1, 6, and 12-inch position. Further, though, our discussion will disregard the weight of a wrench. When the wrench is placed on the bolt, we want to turn. We know with the sum of the effort we'll need to turn the wrench. We'll take 1 pound of weight to apply the effort. The place of the weight of the 1 inch in marking is probably would be enough to turn the bolt. However, there must be agreed that there are some twists to apply with the bolt. In fact, we know exactly how much torque is applied being against the bolt because we have 1 pound of weight pulling down on the wrench and 1 inch from the center of the bolt. The term is used to express as pounds an inch or pound and foot. Sometimes you may see these words in reverse. Actually, the reverse word in inch pounds and foot pounds are used to express power and work instead of torque. We use these 2 pounds, inches, pounds, and feet in this lesson in equipment. We will have placed 1 pound an inch of and 1 pound an inch of twist and torque on the bolt. If the weight is moved out of the weight wrench of the handle, the amount of the twist being applied with the bolt will increase. Remember the lever action we spoke about by moving the weight further on the handle to increase the leverage of the 1 pound weight with applied with the 6-inch mark with applying the 6 pounds inches of torque. The weight is applied with the 12-inch mark with will be applying 12 pounds an inch torque. We can also say that 1 pound a foot of torque is applied, which equals 12 inches is equal to 1 foot. If the wrench is 24 inches long, the weight was placed at 24-inch mark would be applying 24 pounds of an inch or 22 pounds of feet of torque on the bolt. If we remove the weight of the grasp of the weight wrench handle with our hand with the 12-inch mark, we can probably turn the bolt. However, each pound of the pressure applied on our hand, we are applying 1 pound of torque on the bolt because the hand is 1 foot from the center of the bolt. We will pull the wrench to apply the torque of the bolt, and only 15 pound a foot of twist is needed to turn the bolt. That is greatest amount of torque that can be applied with a wrench until the bolt becomes hard to turn. Now, with understanding effective torque, twist has 1 shaft. We will discuss items instead of the wrench turn shaft. These items are called gears. Alright, learning event number 2. Describe the purpose of the type of the operation, gears, and gear trains. An automotive vehicle that must have the same many components that can take the power of the engine delivered to the wheels of the vehicle. Not only the power is simply delivered to the wheels, but the components must arrange with the several things. Military wheeled vehicles are designed the following: have the great pulling power, move at the high, low speed, trailer, and reverse as well as forward. Operate the rough ground with the smooth roads. Deliver power to the front wheels as well as the rear wheels. Simple shaft belt chain from the engine to the wheels will not allow all these things to be done. Therefore, components of the often referred to as gearboxes make it as referred to the power of the train of a vehicle. These units contain various types of gears to do the job. Gears are made in many shapes inside of the purpose to transmit power from the one shaft to another. The shafts might be parallel to each other or at an angle with each other. Type of the gears. You can now see that the gear must be shaped and the job to do so with the current common features. Usually the round wheel with the teeth of the notches formed some way in the outer edge of this. They will have the hole of the center, so they're mounted on the shaft. This shows your external gear and your spur gear. Are the spur gears identified with the straight teeth of the space evenly with the run straight across with the outer face for the gear? This type of the called the external tooth gear because of the teeth are straight outside. The most common type of the gear it will see it was used in the transmit power of one of the shaft to another as long as the two shafts are parallel. While two of these gears in mesh, one can turn the other. One that is doing the driving is called the pinion, the driving gear, and then one being turned is called the driven gear. Notice these gears in mesh, only one tooth of each gear is in contact. This means that the entire load of the being driven from one tooth in each gear. One tooth comes out over the mesh and the other moves in to take its place. Therefore, two things are problematic about this gear. And by having only one tooth engaged at a time, large loads might break off the tooth. Also, one tooth going into and out of the mesh at time causes the gears to be noisy. This shows your helical gears. Another type of the gear is the helical tooth gear. The teeth of these teeth of this gear are cut at an angle. This makes the teeth longer, and the teeth the gears mesh portions two or more teeth in contact at all time. Since the forces on the load of the type of the gear is spread over the large area, the helical tooth can handle large loads of the spur gears can. Also, because of the way of the teeth of the engaged disengage, these gears are fairly quiet. Alright, however, the big disadvantage with the type of the gear with the helical gear driven another gear unload with the gear tries to slide sideways on the shaft because of the shape of the teeth. Driving the gears will try to slide the other way. This action is called thrust. When helical gears are used, the shaft must be designed to prevent gears from moving sideways. Alright, herringbones gears. At times when gears are made to handle extremely heavy loads, the helical principle where long tooth contact is available, the double helical gear called a herringbone gear was designed, and you notice that there's no side thrust or type of the gear because of the shape. This gear is fairly quiet. This is a bevel gear. When power must be delivered to the angle of the teeth of the gears must be cut differently with the type of the gear is called the bevel gear. Note that two of them will change the direction of the power. 90 degrees gears are available to several design. Your spur bevel is a straight teeth, the same as the regular spur gear. Except for the teeth are cut at a 45-degree angle with the side of the gear. Screw bevel gear is cut similar with the helical gear, except for the teeth are cut at a 45-degree angle to the side of the gear. This advantage of screw bevel gear is spur belt and over the spur get bevel gear at the same time those helical gears over the spur gear. The other advantage is design of the type of the gear with the spiral bevel and hypoid, which are used in the rear, front, and axle wheels. This shows the worm gear. The worm gear is another type of the gear delivering power at an angle with the principle of the gear arrangement, similar to the bolt and nut. The worm in the shaft quartz thread cut into it on it and rotates and winds the teeth of the worm gear, and the worm gear is very compact, quiet, and often used for the heavy loads and must be transmitted at an angle. Your internal ring gear, internal gear. Another type of the gear, internal tooth gear with a ring with the gear tooth only on the inside of the teeth. Are usually spur type of the trait across the type of the gear is normally with a special purpose. Your gear principles: speed and direction, rotation, shaft of the gear operated depending on how the gears are arranged. The two external tooth gears are meshed. They will turn the opposite direction. Principle can be used to provide forward, reverse gear of the vehicle. Third gears are added to the gear train called the idle gear. Driving and driven gears will be turned in the same direction. Idle gear will rotate opposite of the driving, and driven gears will not change the speed over the torque of the driving gear. Large drive gears meshed and small driven will increase the speed reverse direction of the rotation and reduce the amount of the torque delivered. A small driving gear matched with a large driven gear will decrease speed, change direction, rotation, increase the amount of torque delivered. An internal gear meshed with a driven axe and external gear will increase speed and decrease torque, and an external gear meshed with a driving internal gear will decrease the speed, increase the torque, but all gears always turn in the same direction. A worm shaft driving the worm gear will deliver power at a 90-degree angle. The shaft is always driven an input member. For each rotation of single thread worm shaft, worm gear will rotate the distance of one tooth. Speed and torque rate of the worm gear set, therefore, determined in comparing the number of threads on the worm shaft, the number of the teeth of the worm gear. Worm shaft is designed in single and double threads. Learning event 3. Explaining the principle of gear torque ratio. The term gear ratio is used to express the comparison of the speed rotation between two gears. It's always stated the first number representing the rotation of the driving gear with the second number representing the driving gear. Also, first number representing the number of times the driving gear must rotate to make the driving gear rotate one turn. Some examples of how gear ratios are stated. 1-to-1 ratio becomes both gears are rotating at the same speed. 2-to-1 ratio indicates the small driving gear is the mesh for the driving gear between twice as big. Driving gear must be turned twice to turn the driven gear once. A 0.6-to-1 ratio is driven gear is best. Every 3 turns it makes the driving gear rotates 5 times. Therefore, the driving only has to make 6/10 of the revolution to rotate driving gear. Gear ratio between the gears of the determine the counting of the teeth, the driving of the driven gear. You must remember that when the two gears are meshed, driving gear rotates the distance of one tooth, the driving gear will rotate the same amount. Torque ratio. To understand torque ratio is necessary to understand the principle of leverage as applied with the gears. And if we recall, discussed applying torque to the belt earlier in the lesson, discussed the torque ratio between the gears. We think that the force from shaft of the gear from the gear to another gear from the secondary gear to shaft is mounted on. To do this, we'll refer to the items input shaft of the gear and output gear shaft of the input of the driving member. The output is driven member. Let's first look at the input member of the first gear with the prevailing turn force of the general gear train. The purpose we'll see the engine and the motor driving the input shaft applying 25 pound-feet torque on the shaft. To begin, we can think of each tooth of the gear being the same with the lever of the wrench we discussed earlier. Remember, the two gears and mesh only one part of the two teeth are touching each other at any time, one time. Therefore, remember the entire load between the two gears of the teeth of the discussion. We will think of the driving gear having just one tooth that is going to use the work. Further understand a little better, we'll say that the gear is 2 feet in diameter. The one tooth was exactly 12 inches long. We said that the torque has 25 pounds applied with the shaft. This means that the torque was direction rotation could lift 25 pounds out of the 12-inch mark at the end of the tooth. This is just reverse. We'll explain with the wrench that how here's shaft of the turning of the gear with the wrench. We wanted to turn the shaft, except we use the bolt instead of our example. By remembering limit laws of leverage, we know the small gear will deliver more torque on the larger gear, and a 6-inch mark with the side of the 12-inch gear instead of the 24-inch gear. The tooth that could fit 50 pounds because of the greater lever to provide with yourself with holding a stick straight out of the arm length. Holding someone who has a small weight on the very end of the stick, you notice how hard it is to hold the weight, and now the person having taken the weight off the end of the stick, handling twice as much weight in the center, you also require the same effort to holding twist the weight in the center as well as to hold the single weight at the end. For this reason, we can see the small driven gear drive gear comparison to the drive gear delivery with a more torque delivery drive a heavier load than the bigger gear. After you have gained experience, you will notice that the driving gear is almost all gear trains is smaller than the driving gear. Driven gear consumption is when you increase speed with the torque with the input with the driving gear would be bigger than the driven gear. Now we see that the mesh of the one tooth driving gear with one tooth of the driven gear. Both gears are in the same size. We think of the driven member of the gear train. We think of it exactly the same as a bolt with a wrench on it. Longer the wrench is easier to turn to the bolt. We said the input of the gear could be applied with the 25 pounds of the end. This is the amount of the force it would apply with the tooth of the driven gear. With the cover of the tooth of the gear is 1 foot long. Torque of the 25 pounds of feet will apply with against the shaft of the driven gear mounted. After remembering our discussion of the wrench, much more effort is required to turn the bolt, short wrench of the long wrench. Therefore, applied input force of 25 pounds against the output of the 24 tooth of 24 inches long. We could get twice as much torque on the shaft of the tooth of the 12 inches long. Here again, we compare with the output gear of the knob you use to wind your watch. As the knob is made bigger with the easier with the blind to watch, and the same principles apply with the driven gear with the gear train with the driven gear is bigger than the driving gear with the increase of the torque. How does it apply with the wheel vehicle? Mechanic looks at a few things of the wheel vehicle that depending on the gears. Beginning the vehicle engine can only produce so much power with the running faster, producing more problem when idling. The power developed with the engine sent with the vehicle to form the twisting motion of the torque flywheel at the end of the crankshaft. And when the vehicle is started with a standstill, a great deal of the torque required to get into the motion. The addition the engine is not running at a high speed at the time the torque of the engine is, and applied with a small driving gear when it turns, which in turn drives the large driven gear that increases the torque and helps the engine to get the vehicle started. After the vehicle motion, less torque was required to keep the motion. The curve of the driving and the driven gear were nearest to the same side. With other words, we want the gear train to develop speed, more torque, more speed than torque. The vehicle comes up the hill, the ratio will have changed again, and the driving gear will have smaller than driving gear to increase the torque, and doing so will give up speed to increase the torque. Sum of the torque ratio we compare with the gear ratio of the driving gear with the 12 teeth of the driving gear, a large gear, 24 teeth of the gear ratio, 2 to 1. In other words, driving gear rotates 2 times the make of the driven gear rotate once, and the gear train with the double torque with the cut out the speed in half of the driving gear, and same side with the driving gear, the ratio to 1 to 1. The input and output torque and speed are the same. If the input gear has 24 teeth and the output gear has 12 teeth, and is 0.5 to 1. Gear ratio with the gear train with the reducing torque of the increasing speed. Figure 8 shows a 2 to 1 ratio. Alright, let's imagine that the crankshaft attached for the illustration above the crank is turned, but the shaft of the cage of the gear at one turn with the same direction crank as the crank. The amount of the torque applied with the shaft that depends on how hard you crank the resistance of the paint of the bucket. Gears 1 and 2 external gears mesh, therefore rotating opposite directions because gear 1 is larger. Gear 2 will turn faster than Gear 1. This will result in the loss of torque. Remember, the gear train will decrease torque to increase speed. Learning Event 4. Describe the construction operation planetary gear set. If often necessary, designer gear trains will provide many gear ratios of necessity, but the trains must not be too large or bulky. The answer requirements of planetary gear system. Choose the planetary pinion, sun gear, and then internal gear, and then your planet pinion carrier. Figure 9 is your planetary gear system. Now the arrangement of the components of the set because of the resemblance of the planetary pinions, planet universal circling around the sun, the set giving them the name planetary gear set. The center of the sun gear can be either the spiral or helical gear contained through the shaft of the village can act as either input and output member. Normally the planetary pinions with the mesh of the sun gear at all times. Some sets will have 2 and others 4 mounted in the free rotate with their individual shaft of the planetary carrier with a framework designed to hold pinions in respective position. Planetary carrier can rotate it so that the pinions walk around the sun gear. The carrier can also contain a shaft so that it may act as input and output member. And outer internal gear with the constant mesh for the planet pinions is called the ring gear. It can also be an input and output member. Principles of the planetary gear set operate with the base of the driven one unit holding the one unit, taking the output of the free unit. If we place the brake on the band around the ring gear, we can prevent it from turning with the sun gear driven under the condition the cause of the planet pinions to rotate. When the ring gear has help with the turning of the planet pinions, will have to walk around the inside of the ring gear outside the sun gear. In doing so, the planet pinions will carry the planet carrier around them. If the planet carrier is held but cannot rotate the sun driving gear with the planet pinions, force the ring gear to turn. If the planet carrier is held with the ring gear with the driven with the planet pinions, will force the sun gear to turn. If the sun gear is held with the planet carrier is driven, the planet pinions will be forced to rotate. They will drive the ring gear. Actual use of planetary gears is such things as automatic transmission and disc clutch, brake bands, controls holding driving members. Usually the bands and clutches are controlled automatically. Or your operating principle. To fully understand the movement of each member of the planetary system, let's consider the few basic operation principles of the planetary gear set. The planetary carrier and sun gear are held together. The pinions cannot turn because of the lock with the sun gear, but this because of the unit with the turns one unit. None of the parts will turn themselves. This will give us direct drive just as it add one piece shaft. Sun gear is held with the planetary carrier with the hole, then the ring gear will turn, but the pins will walk around the sun gear because the sun gear will not move. The pins turning have to walk around the sun gear with the mesh of the ring gear, but therefore the ring gear is pushed. By turning a true pinion, the ring gear will turn with the same direction as the carrier. If the ring gear is held with the sun gear is turned turn with the carrier will turn with the pinions with our mesh with the sun gear. Sun gear's turn with the pinions will turn with the pinions also mesh from the ring gear. The ring gear held together, held with the pinions, therefore walk around in the ring gear. This cause of the carrier to turn with the pinions. If the carrier is held, sun gear turn with the ring turns in reverse because of the pinion of the mesh of the sun gear turns as the pinion when it also turns. However, the pinions turn in the opposite direction of the sun gear. The pinions of the also mesh of the ring gear drive the ring gear because of the carrier's held, but the infinite cannot turn with the external gear is driven with the internal ring. The drive gear direction turning is the same. Therefore, the plant pinion turning opposite from the input rotating the ring gear is in reverse. There are 5 basic rules to planetary gear operation. If the plant carrier is an output, set operates reduction slower speed and more torque. If the plant carrier is an input, the set operates O1 drive, more speed, less torque. If the plant carrier is held and the set operates in reverse. If any 2 parts are locked together, the set operates with a direct drive. If no parts are locked together, if none are held, then the separate operates in neutral. Here are a few more things you should also remember. Input receives the power from such source as an engine. Output member transmit power with the driving wheel of the vehicle. Stationary member, one that holds a band and clutches, cannot turn. Lock members are held together. Speed ranges of planetary sets. Alright, with using the first 3 of the above rules, we can get 6 speed ranges. Remember that we reduce the speed, increase the torque with the wheel, increase the speed with the reduce the torque. The sun gear is held with the plant carrier is turning the ring gear will turn faster for the carrier 1 drive. If the sun gear is held, if the ring gear is turned, the plant carrier will turn slower while the ring gear is reduction. But the ring gear is held, if the sun gear is turned, the plant carrier turns slower from the sun gear. If the plant carrier is held, if the ring gear is turned, the sun gear turns the reverse faster than the ring gear overdrive with the reverse. If the ring gear is held with the plant carrier is turned, sun gear turns faster for the carrier overdrive. If the plant carrier is held with the sun gear is turned, with the ring gear turns reverse slower than the sun, the reduction is in reverse. This shows the practice exercise for lesson 1, learning event number 1, or lesson 1, and we're moving on to lesson 2, fundamentals of clutches. Testing.